So yesterday we talked about a strategy for solving multiplication problems that we don't know by heart, just like that. Obviously, one strategy is you can check your times table, you can check your multiplication table. However, that's not always going to be available to you. So we're going to start learning some different strategies for solving some of these harder multiplication tables that we don't have memorized yet. The example that I'm going to do right now is 6 times 7. 6 times 7. Well, before I even begin, I'm going to model it in an array. Okay, so the way that I make an array here is I just have to put 6 rows, 7 columns. I could also do 7 rows and 6 columns. Because of the commutative property of multiplication, I could put it either way, doesn't matter. But I'm just going to do that like this, 6 rows, 7 columns, and I'm going to push build. So now I have this array right here. I'm going to just make a picture of that. Okay, so now over here I have my array. This array, let's just count to double check. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. This array does show 6 times 7. Obviously, one strategy is I could count each square. However, that would take me a long time, and it's really easy to mess up when you're counting so many things. It's really easy to just, get distracted or just put your finger the wrong place and count wrong. So I'm going to use a different strategy today. I'm going to break it apart. I'm going to break my array into 2. So I'm going to get a pen and I'm going to show you how I'm going to break that. Let's do, there's a few different things that I could do. But what I'm going to do right now is I'm going to break it in half this way. What if I break it in half this way? Like if I just took this, if this was a sheet of cookies, and on each square there's a cookie, and I just kind of broke the sheet of cookie in half. I have cookies down here, I have cookies up here. It doesn't matter if I break it in half, the amount of cookies stays the same, right? The amount of cookies didn't change. I didn't take any cookies away, I didn't add any cookies, I just broke the array into 2 parts. So now I'm going to solve for the top array, and I'm going to solve for the bottom array, and then we'll see what we'll do after that. First, I'm going to tell what my new array shows, and I'm going to actually build you a new array for that problem. So on here, I'm going to say, well, my new array now, watch my cursor, I have 1, 2, 3 rows. In each row, 1, 2, 3, 4, 5, 6, 7. Each row still has 7. So that means the array on the top is 3 rows of 7 columns. So I'm going to build that array right here, and I'm going to create a picture. So here it is. That's the top. Doesn't it match? That's the top. Now the one on the bottom, 1, 2, 3. Oh my goodness, check that out. Since I split it in half, obviously it's going to be the same. So I'm going to create another picture right there. Now I can get rid of this. Okay, so now I have 2 arrays. If I put them on top, you can see that the amount is exactly the same. I didn't take any cookies away. I didn't add any cookies. All I did was break it in half. So I'm going to put 1 half right here and 1 half right here. So I started with 6 times 7. Then I broke it in half. Now I have 2 arrays. The arrays are now, I'm going to type it for you. The arrays are, we counted 3 rows of 7 columns. 3 rows of 7 columns is the same thing as saying 3 times 7. And down here, what about this one? 3 times 7. Exactly, it's the exact same thing. Well, good thing we know 3 times 7 already. We did it so many times. 3 times 7 equals 21. 3 times 7 equals 21. Both of them equal 21 because they are exactly the same. That means there's 21 cookies up here. There's 21 cookies down here. To find out how many there are all together, all you have to do is add 21 plus 21. When we add, we start with our ones column. The ones column is all the way to the right. 1 plus 1 equals 2. 2 plus 2 equals 4. My answer is 42. Watch this. I'm going to pull out a calculator and I'm going to check my work. I'm going to make sure that I went from here to here and I didn't make any mistakes. I'm going to type in 6 times 7 equals, there we go, 42. 42. I made no mistakes. That means that my answer is correct because I double checked it on a calculator. 6 times 7 equals 42. So that's what we worked on yesterday. Today, we're going to keep working on very similar problems, but we're just going to give it a name, which is really good that we get more practice with it. But we're just going to add one little thing, and that's the name of this. We call this the distributive property of multiplication. I'm going to write that so that you can visualize what I'm saying. I'm going to make it nice big font, and how about this green color? Okay, ready? Oh my goodness. Distributive property. That's what this is. Distributive property means breaking apart one of the factors in a multiplication sentence, breaking it apart just so that it's easier to solve. So that means that, let me get a new color, let's do purple. That means that 6 times 7 is the same thing as saying, let's put it in parentheses. That helps us to distinguish the two parts. 6 times 7 is the same thing as saying 3 times 7 plus what? The bottom array, 3 times 7. Okay, these two things are the same. You can break apart 6 times 7 into 3 times 7 and 3 times 7. Then you just have to add them together and you get your total sum. And that is called the distributive property of multiplication.